Yeah, this is the house that we're going to be specifically case studying today, but I have other little examples that I'm going to be using because what we're doing is taking what Ken Nelson brought to us like maybe a year and a quarter ago about the Oasis system. How many people were in the room for that presentation? Oh, interesting. Okay, great. How many people are familiar with this Oasis system that Panasonic rolled out? Okay, I apologize to those of you who are going to be like, what in the world are we talking about? But I'm going to ask you to, after this, you'll get a lot of stuff that has nothing to do with the mixing room method, which is what we've rebranded because Oasis is trademark Panasonic. So I'm not going to say that word anymore. But if you go onto YouTube, you search the Oasis, that you will find a video that I did where I give my like feedback on Ken's presentation, which I was very dubious of at first. I think some of us shared that. Bigger commercial builders, not really probably going to be interested in this. This is a very like niche thing. And there are some rules. So I have gotten a crash course from Ken Phillips on how exactly to do this. And I've got maybe 4 or 5 different projects rolling with this technique that we're going to be doing, which is an alternative HVAC style. Probably not something that HVAC professionals are going to be very interested in either, because one of the strengths of it is that it enables DIY a lot better. But in general, we're going to be talking about HVAC. H stands for? V stands for? AC stands for? Great. Air conditioning and heating, very simple, right? First, we got to get the heating and cooling. You do a manual J, which stands for joule, because it's about energy. A joule is a unit of energy. So you figure out how much energy the house, home, needs to gain in the wintertime and needs to shed in the summertime. Then you do manual S, which stands for selection of equipment to match that. And by the way, this is per room, so that you know you're delivering exactly the amount of heat and cool to each and every room. That's different per season, and sometimes you need to like adjust things seasonally, but generally I try to not design for that. Select a piece of equipment that can be whatever you want. And D is duct design. I'm trying to help as many people as I possibly can. So just a quick background, what I do weekly is I do Zoom consulting, 1 hour. I do this with people all over the world. I had somebody from Puerto Rico last week. I have had people on other continents. I have a guy who wants to do this that we're going to talk about, this mixing room method in Nunavut, which is climate zone 8, which I'm all, generally when we're talking about this kind of thing, I have a big hefty, like, this is an experiment, by the way, you know that. And then they say, yeah, I know, it's okay, it's worth trying. So this is the classic way that we do this. What we're, and I'm going to show you in a second what the manual J, S, and D for this house looked like classically. And then we abandoned it when Eagle found out about this mixing room method and was like, I think I want to do that instead. And so we just reworked, we threw away what we had and we reworked it. However, first thing that we always put on this is air tightness target. Now I'm going to run you through what I call my consulting format. I do this is my Zoom consult format. When people come to me with an addition or a renovation or a new construction, it's always this. We start out with air tightness. How many square feet is the house? And it's going to be 30, in this case, 3,500-ish, right? I've got 3,500 down for today. I don't know where I got that number, but yeah, okay, 3,500. And then we figure out the volume. The volume for this house happens to be 44,000 and change. 44,000 cubic feet. So what you always do is volume divided by 60 gives you your 1 ACH50 CFM50 number. So 44,000 divided by 60, 733. 733 CFM50 equals 1 ACH50. Nunavut, or in Alaska, or in New York City, there's this like 55-year-old woman who knows that she wants to be sub 1. I say, what, do you have an air tightness target in mind? And they're like, I'd like to be sub 1. And I'm like, that's awesome, because they know 1 ACH50 is what we're talking about. Most builders, most contractors do not know this. This is a very typical number that we're shooting for. If you try for sub 1, you're going to hit it. I hit 0.4. Chris and Matt have worked on a house that did 0.0. And I tested that, and you can see that on the YouTube channel too. Like, it's not hard to do air sealing once you actually start trying and you stop bitching about it. It's totally doable. So 733. One trick, by the way, if you want to do passive house air tightness, you do volume, and then you just move the decimal over. Boom, 440 would be a passive house 0.6 ACH50. That's a little interesting trick. So we'll avoid that for right now. I think you guys were shooting for what number? 0.1. It doesn't really matter for the manual J. Just get in the neighborhood, and then you can find out. So what this looks like then when we start using the actual software, the manual J. So you get a report that looks like this. And there's a bunch of videos on the Home Performance YouTube channel about how to, like, if they give you a 2-page report, you can QC that, and you can start doing some stuff. So we can see if we divide the square footage into the volume that it's like not an even number. It's not 9.0, which is like a little bit of a, like, oh, they didn't add the attic as a conditioned space, etc. So you can see here, we've got what we had was a 2.5 ton ducted system. You can see, for example, here that we've got a kind of a weird distribution. If you do these a lot, this is pretty weird for it to be like a lot of walls, a lot of ceilings, and then not very much glass or anything else. Even in the summertime, it's not mostly glass. This normally would be the yellow, which is glass. This is ceilings, and it's because of the shape of this house. This house is mostly walls and ceilings, right? And the insulation on this is, anybody want to guess? It's ground, it's 2 feet of dirt, and then R8 of EPS. 2 inches, and that's it. So like manual J is not built for that. So you kind of have to play with it a little bit. What I assumed here, and you should always get this report right here, which is called the component constructions, figure out what the person assumed. So I said 24 inches of soil is worth blah, blah, blah. It was about R value of 0.4. I did some research online, and it's like if the soil is wet, if the soil is dry, if the soil has this much dirt content and rock content and sand or whatever, it's like, it was too comfortable to just be conservative. In general, you want to make sure that we don't undersize this thing because there is fat built into this. Okay, so then we ended up with a duct design that looked something like, right, you can see that there's like a return, and we got these ducts, these round ducts that are 10 inches or 8 inches or whatever. We got our makeup air coming in over here. We got our system in this closet over here. So that's what we basically threw away. And by the way, just because this is interesting, I have worked on other Hobbit houses before. And this is what, so these guys wanted to build this prototype. It's like an upside down pool, fiberglass pool enclosure. Theirs is not fiberglass. This is like poured concrete that they had to form up, and it's pretty awesome. This thing they wanted to commercialize and sell in every climate for any direction facing and meet code, have like a set of reports that's like, this meets building code, this meets, you know, all the local whatever. And basically their problem was that this is a lot more glass. Eagle has glass here, a reasonable amount, and here, a reasonable amount, and then none anywhere else. This over here, which is echoes this size, is the garage. So this thing has way too much glass, and it looks like this when you look at what's called the adequate exposure diversity. So sun comes up at 8 a.m., sun goes down at about 7 or 8 p.m. This is what the sun just does through the windows. This is Elite, which is a separate, it's not right soft, and Elite has this ability of room by room tracing of this. So you can see that this room is crazy. It starts out way down here and goes up to like about double what it starts out as. Some rooms spike early, right green with blue dots. Some rooms spike late. Some rooms spike right in the middle of the day and then just kind of go down. So that kind of information is really useful. That's why you do the computer modeling. This is what happens when you rotate the building. Like we need 0.5 ton down here if you face south. We need 0.8 tons if you face north. You can't have, so basically it just didn't work is what I had to tell them. It's like, sorry, you can't do this. They're doing it, these guys are doing it actually right. What we end up with is here. This is what I'm gonna drive towards. So what we're about to do is we're talking about like Hobbit House stuff, underground houses. And that's interesting. And we've kind of left that for a moment. What I now want to go through is the 5 factors of ventilation, which is the V. Most people think V is just one thing, which is how much fresh air do I need to get into the house? That's not it. Because there's a whole bunch of stuff after you've done enough manual J, S, and D that you're like, it's not in here. Even if you do manual T, there's like things that are not really built in. Like what happens when the variable speed heat pump turns down its fan? Like my family and I all have like Mitsubishi pieces of equipment which have multiple settings. You can set it, it's gonna run all the time. But you can set it at low speed, you can set it at medium speed, high speed. What happens? Like, because we're designing for one thing. You pick your grills for one thing. That's manual T is terminations, by the way. So it's your grills. And that's not built in. Like, how do we predict for that? And that's what testing is for. That's why you want to go in and test after you're done with the design. So in order to get here, first, we're going to go here. This is a report that we get off of this website right here. This is called ashray-medio.info. Just as a reminder, I have put all this in a video. If you go to my website and you search consult, you will find a video where I do an imaginary, stupid, crazy house that my children drew. And I do this, and I show you all of these links, and we do this again. So if you want to see it on a different house, that's where you can do that. We pick the, you've got all of the weather stations the whole country showing. We pick the one that we're going to use, and we get our coldest temp right here. So coldest temp is 26. 99% coldest, 99% hottest right here, 91. And I always say to a normal person, don't worry. I know it gets hotter and colder than that. You don't have to care about that because spikes are built in. And the wettest temp is 81, not 91, right? So then that's when we need to do, because again, manual J cares about what temperature? Hottest, the 99% hottest. It doesn't care about the wettest. It's not telling you what the load on the wettest day is. You have to figure that out separately. So what we've got here is the 5 factors. We have number 1, circulation. Number 2, capture and filtration. Filtration being a form of capture. Number 3, humidity control. Number 4, dilution air. Number 5, pressure relief. Let me say right off the bat that what is not on this list is ionization or UV or whatever, hydroxyl radicals, stuff like that. Don't do any of that stuff. They would love to sell you that stuff at the supply house. They're pushing it really hard on you guys, right? Is in the front when you walk into a supply house? Front stack, that's right. It's an easy way to make $1,000 on a piece of equipment. You guys upcharge on the install, walk away. You don't sell that, that's good. So HVAC students particularly, do not do any of that stuff. It's total BS. Those people do not know what they're doing. And I know that because I talk to world-class chemistry researchers, and the chemistry researchers say they don't know what's going on with those. And if they don't know, the little researchers inside the company who are paid to like make a thing that's to be sold, they definitely aren't telling the truth. So capture and filtration, humidity control, plus humidity in the wintertime, minus humidity in the summertime. Dilution air, and that's pretty constant. And I'm gonna go through all these targets and everything. And then pressure relief. And this is mostly for one-way exhaust fans, but we're also talking about like room-to-room pressures. So you don't wanna give too much air, which is one of the problems that we're gonna have with this design, particularly when we get there. So 5 factors. Number 1, circulation. We need to know that we're moving air between rooms. If I mini split everything, ductless mini splits in the whole house, do I have circulation between rooms? No, you do not. Okay, so then we need to like, okay, think about that. Because then also mini splits, let's just go through this real quick, because this is a joke that sometimes a person really needs to hear this. Sometimes they need to hear it twice from me, a year apart. I'll have to do the whole joke. I can give them the punchline, which is that whole house mini splits don't work. You need a duct system. But the whole joke is that you don't get circulation. Do you get filtration with mini splits? Nope. It's not MERV like 3 or something like that, right? You can see through them. It's not going to work very well. Do mini splits do dehumidification very well? Nope, they don't. And they don't give you a mechanism for distributing humidification around the house either. And we don't have a pathway to do dilution air. So the punchline is in my studio in my house that we built, which Chris helped build, with several people in the room have like visited our build site and helped out. We have a ductless mini split on the wall of the studio. And then I have 3 duct systems in the crawl space underneath that thing. So if you want to make your life more complicated, cool, let's do a ductless system. But if you want to like try and make everything integrated, then it's a little easier if you do it the other way. So it's either a ducted system or some kind of a duct, like what's been called in this instance, what we're about to get into with this patented Oasis trademark symbol, or mixing room method, which is what I call it, or distributed ductless, which is one of my other clients is calling it, or Matt's mixing room, which is what Matt Hoots wants you to call it. Who hates ceiling fans? So ceiling fans solve a lot of problems. We don't have to do manual T to select the grills. We don't have to care what velocity it is coming out of the air. If the air in this room is coming out of a supply right on top of the door, with nothing else going on in this room, what it's going to want to do, if we're using the door undercut as the return, which you can totally do, it's written into Manual D, door undercuts, great, 1-inch door undercut, 3-inch door, 75 CFM return. If we're using this door undercut, which let's say this is 2 3-foot doors, which is 150 CFM that we can give back, it's going to come out, it's going to immediately want to go back out. It's not going to go anywhere near your face, right? So that is a problem. But if we add a ceiling fan on low speed, upward direction, everything goes away. Every single surface in this room is exactly the same temperature. Every corner of the room is exactly the same humidity. Beautiful, right? So it's just like a Band-Aid that it does work. So my ceiling fans are locked on. You cannot turn them off without a screwdriver. Get a little piece of plastic at Ace Hardware. It's good. So distribution of ceiling fans. What I like to tell people is if they say, oh, I hate those things, is at least wire for them so that then in 5 years when you're like, man, with this temperature stratification in this room is driving me nuts. Or we're getting some mold forming over in the corner. Ceiling. That. Now we need to go to capture and filtration. Every time we go down a layer, we're going to go back up and revisit and make sure that we're doing, like for filtration, how do we get to filtration? To be distributed. Capture. So what we want to do with capture is code says, this is in the International Mechanical Code. I'm going to flash it up on the screen right now so you guys can see. When you have a code official come back at you with something and they say, you can't, they only have 1 bullet in their gun. This is a universal truth I have found. They shot their bullet, and then if you come back with anything at all on a letterhead of any kind, you win. They'll be like, okay, cool, got it. Because they don't really care, honestly. They just want it to be done right and they want to like shoot their shot. So in bathrooms and toilet rooms, in 1 and 2 family dwellings, this is from this table in the International Mechanical Code, you either need a 50 CFM exhaust fan that you turn on and off as needed, or 20 CFM continuous. If you call Brown Technical Support, which also is owned by the same company that owns AprilAire and Santa Fe, they will tell you that you need to do both. It's and. We need to size this thing for 20 CFM continuous, and then when you take a shower, we get a boost. How many people have been to my house? Okay, cool. In my house, were there any boost buttons in any bathroom? No, there are none. Okay, so I used mine as an experiment to see. There's no flex duct the last 3 feet to cut down on the noise. There's no boost buttons in bathrooms. My house works perfectly well. The backside of the shower glass has never gotten foggy. The mirror on the other side of the room has never fogged up. So 20 CFM is perfectly fine as long as you never shut it off, right? It's constant. So that's an important table to visit. So what we're doing here is 20 CFM sized for each shower or separate toilet room in like a master. But what I do, because you can do this if you want to, is I do 25 for the showers and I do 15 for the toilet rooms, because a toilet room is going to be necessarily very small and a shower room is going to be necessarily like pretty big. And then 5 for a litter box. I always ask, like, how many cats do you have? They say 7, which is illegal, by the way, in the state of Georgia. That's hoarding. They say 7, you say that's illegal. And then you say, how many litter boxes? And they say 7, right? Or they'll say 8. It's number of cats plus 1 is like what the online stuff. So then you do this, right? And then we come up with a number. And in this case, Eagle's number is like, let's just say, I don't have it on the tip of my tongue, I'm sorry. But let's just say it's like 120. Okay, then we do 1 air cleaning per hour, which magically is that number. It's the same as your 1 ACH 50 number. So 733 CFM 733 CFM through a nonstop will give you 1 air cleaning per hour. Now here is what we need to really revisit. This is rule of thumb HVAC, like cooling sizing. Really, any high performance house is going to end up somewhere between 1,000 and 3,000 square feet per ton. And I know that because I've done hundreds of these things all over the country, and it's always this. Matt Risinger builds around like 1,200 to 1,500 square feet per ton. People who are doing passive house stuff can exceed 3,000 square feet per ton. And the number of square feet is important because Manual J thinks how many feet is a floor level? 8 or 9, yeah. So that's like what Manual J is gonna be like, yeah, that's a floor. So if you have 16-foot ceilings everywhere in your house, Manual J is gonna think your house is twice as big. And so that's okay, that's good. So you're gonna use that as the square footage. So in this house, 3,500 square feet, what's our window of sizing? 3,500 square feet, somewhere between 1 and 3 tons. HVAC, guys in the room, put your old school hat back on. Does that scare the crap out of you? Okay, and also it's not even that range. And they'll say, that's a really big range. And I'm like, that's right, we're gonna pick in the middle. So we're gonna go 2 tons right in the middle, right? And if you put your house underground partially, if you have a basement, we lower it even more. And if you build volume on top of volume, you build like a more cylindrical shaped house, we lower it even more. So it might be as low as 1 ton. In this case, I think we're all of our models are like severely overcompensating because we don't know, there's no software that's built for a load calc that's underground homes. So 2 tons is how many CFM? 400 square CFM per ton is 800. So 800 is what we've got. 733 is 1 air cleaning per hour. What MERV level am I gonna recommend for these people? MERV 16. MERV 16 in the AprilAire 28 by 31 size, which is called the 2516. It's we like it because it's very, very big. Number 1. Number 2, they test their stuff. They know what the static pressure drop across the filter at all of the different airflow levels is going to be. So this is going to be a MERV 16, which is just shy of HEPA. I say HEPA starts at MERV 17, so you're getting almost hospital quality air filtration. Great. That way you can run your thing at auto all the time. And MERV 16 is going to take 95% of all the particle stuff, big and small, out of the air in 1 pass. Bam. So you can have a party, you don't have to worry about it. Now we've done with capture and filtration. We're gonna make sure that this stuff gets distributed, which is what we're gonna do when we convert over to this other thing. Humidity control. We wanna minus mainly for us because it's so humid. So dehumidification is the grains per pound delta times the CFM, because what is our load? What's creating the load in a high performance home for humidity? The ERV, the ventilation is bringing in the stuff. The internal, if you haven't set up the shower exhaust right, could be giving you some. If you're not exhausting from the kitchen right, you might have some internal humidity, but normally it's gonna be that ERV or HRV. ERV or HRV, by the way. Okay, so the grains per pound that we're aiming for here is 35 to 65. That's your range. What this is 65 is 50% relative humidity at 75 degrees. 35 is 30% relative humidity at 70 degrees. So there's your like kind of comfort zone for most people, and I just aim at that. If you're the kind of person who's like, I like 0. Cool, great. Let's talk about it, because that's why this is dependent on you guys learning how to do this and walk people through it. Because like for stuff, people use AI and they tell me that the AI disagreed with me, and I'm just like, so anyway, you'll deal with that. But they're not going to go to AI to design their whole system. They're going to go for a first glance, second opinion, and then they're going to go to a real person who they trust. That's you guys. There need to be more people who do this kind of stuff. So when we're doing dehumidification, we're trying to drop from whatever to 65. We can see here, the wettest condition is right here. It's called humidity ratio. That's grains of moisture per pound. We're at 131. So 131 down to 65 is we need to take 66 out of the air to get down to this level. We have a CFM that we're going to be running for our ERV, which, by the way, to come back to capture, we need to capture in bathrooms. I jumped straight to ERV. The reason we can't use bath fans in this house is because of depressurization. So we need to go, and what you do is any depressurization is a function of 3 things. So it's the CFM 50 of the building leakage, which is why we did that thing at the very beginning. Then we've got our exhaust flow. And by the way, this number, this 150 CFM 50, is their magical 0.2 ACH 50 that they're really aiming for in real life. You can solve for either the building leakage, the exhaust flow, or the depressurization. We're solving for what the depressurization is going to be. If we take a house that's this tight and we pull on it 50 CFM, it'll depressurize the whole house to 10 pascals. We can't use bath fans in this house. It's not even an option. I got her house to negative 37 pascals with all the bath fans and her kitchen exhaust hood that there was no makeup for. And he was able to solve the problem by actually installing the right stuff. We had to remove all of her bath fans. After you uninstall all these perfectly good Panasonic Whisper awesome fans, and you got to patch the drywall because the ERV ports are smaller and all that stuff. So that's why we didn't even consider bath fans. And most of my clients, I talk out of bath fans immediately because they're like, I want to be super airtight. And I'm like, cool, you said the magic word, you can't have bath fans. And they go, oh, cool. And hopefully they've been watching the YouTube University for long enough to know, cool, that's what I was planning on, is having the ERV run my bath. By the way, you can't have a vented dryer in this house either. We jump up to 150 here. That is a building, that's a blower door test. Wow. If you have a vented dryer, it's not going to work. And I have a video about why just adding makeup air to the laundry room is also not going to work because of a bunch of things that we don't have time to get into. So we used this. We came up with the 66 delta grains per pound. We need to know what the ERV is actually going to be running. And we have 2 targets that we're aiming for. We have this target right here, which is how much do we need to pull out of the house. We need to know the other target, which is how much do we need to pull into the house. 7.5 CFM per person, plus 3 CFM per 100 square feet, or 0.03 CFM per square foot, minus blower door, minus filtration on AprilAire 2019, 62.2 2019. And what that looks like is over here. So this is all free. These calculators, I get paid more than a lawyer in some places in this country to do free calculators that I show people how to use on my YouTube channel. Offer this service. If you get good at explaining this stuff to people and making them feel like, okay, good, I understand this. Like that's what I'm doing tomorrow with these folks, is like I'm gonna have the contractor and the client, and I'm there to just like make sure that everybody understands all the different options. It's really not rocket science. All you need to do is be able to like talk about this stuff well enough. So we get all this stuff in here, 3,500 square feet, 5 occupants, which is 4 bedrooms, 20-foot height, 150 CFM leakage, and we end up with 143 CFM needed every minute of this home's life, but we can subtract 5 CFM for air leakage. We can subtract 29 CFM because of the nice filtration that we're doing with these giant MERV 16 filters, or MERV 13 actually is what we have to do in this house because of things we're going to get to. And then we end up with 110. So 110 is our fresh air. Which one's higher, 110 or 120? We go with 120. This is the magic number now. We're going to shoot for that. So you set the ERV up to do 120 in, 120 out. We're over ventilating, which means you're going to get a really nice CO2 reduction and all that stuff. That's nice. But we have to shoot for one of these and we want balance. So higher number is what wins. So we now can plug in here 120 on our dehu. And then we multiply by this coefficient right here. Who can do this for me? 66 times 120 times 0.0148. 117. 0.216 we'll ignore. 117 pints per day. That's 117 pounds per day of liquid water we need to take out of the house. ERV is going to strap that in half automatically. And if you get one of these nice, no offense, sponsor, I love your filters, love your dehumidifiers. But the Panasonic ERV they just came out with, which is competing with the Broan, it's actually got about a 10% better efficiency on both sensible and latent. So we could cut this by half. Let's just say whether you use a Broan AI, which is what I have in my house, or one of these Panasonic things, which is slightly more effective and slightly cheaper. Tell your bosses, please. So we cut this in half, we come down to about 60. 60 real life. What pints per day can really do a 60? A 70 can't quite do it, but we're at 80 degrees, right? Is the air conditioner still gonna be running at 80? Temperature is actually 81 right here. So that's the peak humidity temperature is 81. So is the AC gonna be running on an 81 degree day? Can we depend on the AC to be pulling 5 pints per day on that day? Yeah, I think that's reasonable. So we could do a 70, which is good because the 70 is significantly smaller airflow than the next level up, which is a 100. Okay, so then we've got that. So now we're gonna do a 70 pint per day dehu. We got humidification. This is always gonna be really small. The grains per pound is, at driest, we got 9 grains per pound. We're gonna wanna go up to 35, so we're gonna do 26 added. We got 120. I might add to this air leakage, which was 5 in this analysis I just showed you. So I'll go to 125 because it's gonna be a very cold day that day, not mild like the humid day. So 26 times 125 times 0.00185 is 26 times 125 times 0.00185, 6 gallons per day. Again, ERV cuts it in half. 3 is our actual number. That's 3 1-gallon humidifier. Like, just do that, right? Because to buy a steam humidifier system and inject it in is like, and you're gonna get 36 gallons per day on AprilAire makes it very nice. If you guys keep the modulating one in there, it goes from like 25 to 36 or something like that. That's still, even at 25, it's 8 times bigger than it needs to be. Like, we really don't need something that big. So they make a 14 pint per day, or gallon per day one at HVAC Quick, but it's still like $1,500. So why are we doing that? Okay, so bam, we've gotten through this. We want to make sure that this air and this water, in the case of the humidifier, gets filtered and gets distributed around the house. Next, we go down, we skip this because we already did it. Pressure relief. You have 2 choices, passive or active. Passive means we open a hole to outside and we let air come in. You go here to Brown tools, resource tools, specifier tools. Go down here, range hood, makeup air specifier. Enter all the details. I have videos on this. I'm not gonna show you this right now. One thing that I will point out is that you put a 400 CFM fan. By the way, do we need makeup air for a 400 CFM range hood? But do we need it according to the letter of the law? No, you don't. The code guys don't know what they're talking about. Out of a 400 CFM fan, ducted with 8-inch round, 10 to 25 feet with up to 2 90-degree elbows, you're gonna get 420 CFM. Because they know the fan curves, and so they're programming this. By the way, this is for Brown stuff, which you can honestly pick any, like it doesn't matter. They're just gonna tell you how many. We say process. How many 6-inch or 8-inch or 10-inch makeup air ducts do you need to make up a 400 CFM range hood on a house that's this tight? How many people wanna make 4 10-inch round holes in this house?
No filter.
With no filter, and each of these things costs like $450, the mechanical dampers that size. Or you can do it with 6 8-inches and 1 6, right? And this, then I print this out and I say, this is why you're not gonna do the passive option, and I'm gonna sell you on 1 8-inch round hole to outside with an active system instead. So this is either 4 10-inch rounds, the MUAH or MUAS 8. This is an active system. There are other options. I have not seen them in person and tested them to know that they work. I have that one in my house. You guys saw that in my crawl space. So that's what I would recommend. Bam, we just went through this. Okay, now let's go on to what we were gonna talk about here, which is what really happens when you start trying to do this mixing room method. So first thing that you need to do is we're gonna take the manual J, which is a room by room manual J, and it gives us how many CFM need to be in each room because it's a proportion of the BTUs that are gonna be delivered by this thing. Ducted heat pump or furnace or whatever. We're gonna throw that in the garbage. It's good that we did it because now we know how far off we're gonna be when we do what we're about to do. So now we're gonna do this, which is delivering to each room with a fan. And you have 2 choices. You have a 50, 80, 110 CFM fan, or you have a 110, 130, 150 CFM fan. So here is what the actual report looks like. Now this is Eagle and Matt were the first ones who wanted to do this. So this was my first glance at this. You got rooms, right, which are just areas. They don't have to be like kitchen and living room. In his case, are connected, so you can call them living room and kitchen, or kitchen and dining. Square footage, volume, what the 4 ACH is. And then we know from this how many fans we got, and then what type of fan, and if there's a second type of fan, like we want a couple big and a couple small, what the secondary is, and then what fan range we're kind of looking at over here. So this is not super smart. To give you an example of why we have a problem here, This room right here, walk-in closet 2, needs 42 CFM. So it's going to get one 50 CFM fan. We want to generally aim for all these fans. Let me back up first. What Ken Nelson, one of my clients, dragged Ken from a conference into one of the consults and said, please tell us how to do this because you're not going to like do it for me, you told me, so just tell me how to do it. And they were like, okay, great, here are the rules. The rules are not above the 40th parallel. I believe he might have said that in the presentation that he gave to us, which basically is Tennessee. So climate zone 4 max is what Panasonic will do. I had a guy this morning contact me from Nunavut, which is climate zone 8. And he's like, I'm so hot for this. This is exactly what I need to do. And in general, I'm always like, you know, this is an experiment, right? And they go, yeah, it's okay. I'm like, okay, I can't guarantee anything. This is like totally outside the box. Cool. And then it's normal people, not Steven's company that like is building production, style, because it's going to be, the tweaking is going to be a problem. What we end up with, we want the second rule to be that the mixing room has no load. So it can't have its own load on an exterior wall or on a roof or something like that. Internal stuff too, like don't put your laundry in there also. It needs to be really clean because we're going to use this room to mix all this stuff and it needs to be really a clean room. And also, my rule is that we want these fans to be on low speed, ideally, or medium speed max as a default. You do not want to size this like so this 115, we wouldn't want to size the 80 or 50, 80, 110 and run it on high all the time. We're going to do the smallest one. And if it's 90, I'm going to do, instead of going medium speed on the big one, I'm going to go ahead and pick the biggest one because the next room over, I'm going to downsize a little bit. So there's still some thinking that needs to be happening here. Here's an example of like a better way to do it. So this is a slightly improved version. And what we have here is room, square footage, ceiling height, volume, so that you can kind of break all this down and I could just do it in easy, this equals this times this. For ACH target CFM, then fan large small, then target flow CFM, so 96 becomes 110 when we actually plug an actual fan onto it. Then max flow CFM because we need to size the return for what could happen if, weirdly, we don't think it's going to happen, all the fans kick onto high speed at the same time. You'd want to know that the house would still function, okay? So this is like really what I think is right. Now the grayed out ones are loadless rooms, which classically in Manual J, you would not assign a supply duct to because they do not need any conditioning. But what that means is that we're this 35.6 CFM, we're not supplying at all, right? So then we might end up with enough of those without oversizing other rooms that we end up in this scenario here, which is another one of my clients that's gone back and forth. They're having some problems. They had to go back to their structural engineer because these guys needed 41 fans. How many fans do we have in? 27 fans, 27 exhaust fans. These are things that are like 16 inches by 16 inches. And if you think about this mixing room that Ken was showing us for a 1200 CFM Japanese apartment building, that's fine. That's 4 or 5 fans. 27 fans is a lot. And you guys are having to do some serious thinking about like how to design the room. So basically what I did as the designer is gave Matt an IKEA furniture set without any instructions. And I was like, I know that these are the right pieces, but you're gonna have to figure this out when you get to the framing and you look at things and you're like, okay, well we can't do that because the door is gonna open and it's gonna be weird. And so basically they had to work really hard. How many extra hours would you say this added to your process? I'm not trying to make him show off in front of you. I just want to know, like, honestly. The problem, okay, but on the flip side, the benefit of this, in case you're like still like, why in the world are we doing this, is because it can be DIY install, DIY maintenance. One of these fans goes out, you literally go to a big box store and buy a replacement and install it yourself. So we don't have to wait for highfalutin HVAC pros to be trained all over the country and to understand this stuff and to not be afraid of it and to like not charge $10,000 because I don't understand this. Also, these fans can be ducted with 4-inch if it's a smaller fan, but it's better to duct them with 6. And the bigger fan, you can duct it with 6-inch, but it's better to duct with 8. And so I'm like, when Ken came, he was like, you just run 4-inch flex all over the place and it's fine. And so we've been kind of like looking into it and I was like, we don't really know. Panasonic they haven't written a book about this. And they're not leaning on any standard. And in fact, the reason that they picked 4 as their number, a 3.5 ACH, which is like a more reasonable version of 4, is because old dudes wanted 4 ACH. So I think that they were just trying to throw a bone to like people who do HVAC and have done it for 50 years or whatever, and like, I know what I'm doing. And they're like, yeah, you're right, 4 ACH. Here's how we're gonna like, just turn it on its head a little bit. So in this case, the problem that I like to point out is that we have 2 systems because this house is They designed the house without any room for HVAC, and they thought that mixing room method would fix it for them. And it's not going to. And so here's one of the problems. Purple is a separate system from white. Gray is still loadless rooms. And what we end up with is a total CFM of 2825, but 3.5 for the whole house is 4,300. We're way off on this. So this is like not a great situation. So I'm now saying, we got to get closer to this thing because this isn't even 4, which is what we aimed for. And I think 4 is a little bit safer. Nobody knows what's going to happen, right? That's basically the end of it. So here we just got to do something to bring this closer to the actual volume of the house divided by 60 times 3.5, which is 4,300. It can't be that low. Okay, does that make sense? Having to do is really leaning on the CEO, which is the homeowner. In most of my experience, it's like that person is going to be the one who cares the most, who's willing to take the time and pay the extra for the extra consulting and the extra site visits or whatever that needs to happen. We put the target in here. So what I've got on this, which is like not the best way, I'm kind of experimenting still with how I'm formatting this, but in RightSoft, for those, how many people use RightSoft? Okay, here's what you do. Don't make it a ductless system. What we did here is we've got in this little mixing room, this thing is the air handler. And I just didn't connect any ducts to it. And if you make it ductless, you can't add any ducts on the software. So then you can't do ERV, you can't do like it really screws up your flow. So make it not a ductless system, don't assign that, but make it, the air handler is in here, and then you can assign it to be a ductless system in the equipment selection. Sorry if that's too technical. So then we put the ERV, the ERV is just dumping its fresh air into the mixing room. Dehu is just dumping into the mixing room. That's a portable dehumidifier, by the way, which if we've got 60 pints per day needed, we could just buy, instead of buying this, which, no offense, again, $2,000 piece of equipment, you could buy 5 portable 50 pint per day dehumidifiers for that price. And that's one of the things that we're saving here is that like we just saved $2,000, I mean, not $1,600, right away, because we just experiment with 150 and see if that covers it. And if it doesn't, just go buy another 50. Like, who cares? And you just plop it in there and you drain it to the, into the drain line. Okay, so then we've got all this stuff dumping in here. This filter wall is a big deal. What we do is we size this thing so that it's 300 feet per minute. And you can use a calculator online. How am I doing on time? Anybody? We can come over here to CFM. There are CFM calculators online. Yeah. And we go for the CFM that we're totaling out, which is like, what did I just say? Okay, this is 2941 total CFM. See here, I didn't have that extra thing of what the actual CFM delivery is gonna be. But let's just say it's 2941. So we put that into the calculator here, and then we just start experimenting. And what we want to do is aim for this feet per minute to go below like 300. So let's say it's what I just said, which is 18 by 96. And bam, there we are. Okay. So this is with a grill on it, right? So a 0.8-ish net-free area. So 80% of the grill area is not made up by metal or whatever is in the way. 2941 CFM. Through this size, which is 1.5 feet wide, 8 feet tall. What we were initially talking about doing is make a little hallway that was like lined with rock wool so that they could go in and around and kind of like that rock wool tunnel that they have at the build show sometimes where you like walk in and you can, oh my gosh, it's so quiet. That was what we were thinking. But then Matt found this other way of going up because it just wasn't gonna work with the geometry. So as long as it's this cross-sectional area, which is whatever that is, right? 12 square feet. And that's how they came up with this AprilAire double cabinet thing going through there. So then you can see the geometry of all that stuff on their channels. So we can start slowing down and taking some questions at this point. Because I feel like we've gone through the 5 factors. All of those 5 factors are built in here. We're using all these things in this room now, and we're distributing them with these 4 ACH per hour per room fans. And it's being installed now. Basically, yeah, so you've got this filter wall that allows you into this room. The room is like a clean room. You got all your stuff in there parked, dumping into the air. And it's having enough, it's 3,000 CFM coming into this room. And then blasting through the room and coming to this wall where there's all this array of fans. And in this case, we got 29 fans. In the other case, we got 41 fans. It's like just, I recommend for ERVs, these adjustable grills that are Fantech. They're called the MGE 4 or 6. And they can be adjusted. Don't get one that can't be adjusted because then you have to go up and you're messing with manual dampers and stuff like that. Or you can't adjust it at all. So in this case though, you don't want to choke it down at the end of the run. Don't choke anything. So we don't want an adjustable arm or anything like that on these grills. And you could just the easiest thing would be to take the 6-inch or 8-inch and just go boop, and there's a hole. But what Ken was recommending to you guys is Panasonic. Remember, this is like, but I think it was just a bunch of dudes sitting around in the break room being like, why don't we just do our own HVAC system? And they're like, actually, that's not a bad idea. So I don't know how much science and research they've done on this, but if you take that 6-inch and you just dump it into a boot that's way bigger, so like went to a 12 by 12 instead, it'll slow the air down a lot. I actually don't know if we want to do that. If you don't have ceiling fans, if we don't have ceiling fans, you want the velocity coming out of that fan to be enough to mix the air in the room itself. I think so. I think it would be nice to have it be the 500, 700. However, that difference between 50 CFM and 110 CFM is like kind of, so again, how are we aiming for the size, for the velocity to be at the 110 number? Which, by the way that this is, the concept is supposed to work is that you use these Panasonic Swidget. They partnered with this company called Swidget that are all these little plugins. So per room, you have a nose, basically. And the thing says, this room is getting a little hot, which I don't understand how it would know that it's like seasonally, that it's like, oh, hot means that there's not enough HVAC, or if it would be like, oh, it's hot because there's too much HVAC in the wintertime. So I'm gonna leave that with you guys because that's not my job. But that it would say this room is stinky, more airflow, or this room is hot or humid or whatever, more airflow. So it would basically communicate directly with that fan that serves that room and say boost up to the medium or the high speed. So we don't think that any of them would be able to click on high all at once because that would be a really weird, I can't imagine what scenario that would be aside from like somebody bombs the house or something. Let me say one other thing, by the way, which is like, what if we did the mini split? Because I've had people say, I want to do mini splits and then have a duct system that delivers filtration and dehu and ERV. If you dump the ERV here before the filter, which is good for double filtration, you dump the dehu into the supply so that we can have the evaporator coil and the dehumidifier both drying at the same time. If we don't have this thing, then the dehu only runs when it's wet in the house. The humidifier only runs when it's dry in the house. The ERV runs continuously. The filtration is nowhere near, we need, to get one air cleaning per hour, we need 800 CFM. Anybody have an ERV they've ever seen that runs 800 CFM in a house? That doesn't even exist. So now one ductwork isn't gonna work. If you oversize this ductwork to handle the max capacity, what'll happen is it's so big that now when the ERV is running all by itself and whatever filtration thing, it's got all the room in the world, it's just gonna come out the first thing possibly. It's not gonna go all the way to the end. So that's one of the problems with that. If you've got, it's not online, so I can't show you, but there's a Munters app that's free. You search Munters, and they've got a mixing calculator in there. So if you take 2,900 CFM coming into the room, and let's say that the mini split, in this case, is a, 3-ton? Is that what we decided on? Because of some things with the discrepancy with the heating and cooling and whatever. We set it on 3-ton. How many CFM are coming out of that 3-ton wall unit? About 1,200 CFM. So let's say of the 2,900, 1,200 is going to be at whatever the mini split's delivering at, which is like, let's say that it's dropping at 20 degrees, just to be nice. So it's coming in at 70, coming out of the mini split at 50. So you'd put 50 in here, and I could actually do this if you guys want. So mixing app right here. So we got one airstream that's coming back at 70 at, let's just say, it doesn't even matter. Let's do summertime. So 70 degrees, 50% relative humidity returning. We're going to do, what did I just say? 1,200 CFM, right? And then the remainder is coming through. It's just on its way through. Oh, so I'm sorry, that temperature is going to be 50. What relative humidity coming out of a mini split? Do we think like 90? Let's just call it 90 for the sake of argument. Okay, so then 70 at 50% relative humidity coming through. That's 2,900 difference would be 1,700 difference. So then the mixed air is going to be 2,900 total CFM. We got 62 degrees dry bulb, 63% relative humidity, dew point's 49. Nothing is wet. Because it's just a huge volume of air. That's why this is okay. In my house, I have a totally independently ducted ERV, and I would not do it again. I would do it this way because it was just a lot of extra work. Yeah, so it's just the benefit doesn't outweigh the cost of what it took to put that thing in. One is, let's stick with what we were sticking with, which is a 1,200 CFM air handler. Let's say this is still Eagle's house, and we're still using exactly the same sizing that we had. It's a 3-ton partly because it's not a hyperheat unit, by the way. So this thing, and it's at the top end of our size that we had over here. So this thing is moving 1,200 CFM. If this ERV is the ERV doesn't even matter, like Dylan was saying. Dehumidifier, let's say that's the biggest dehumidifier that they make, which is 500 CFM. So we got 500 CFM coming in here. The thing is pulling 1,200 CFM. And I used to think like, oh, that's 1700 CFM. It's 500 from the dehu, but it's not. It's the air handler is going to pull either from wherever it can. So it's going to get 500 because that's being forced fed to it. And then it's going to take the remainder from over here. So now it's taking 500 CFM of dehumidified 90-degree air at 20% relative humidity, let's just say. And then it's getting the remainder at the rest. That's why we don't do this, is because then the air handler, this evaporator coil in here, cannot dry anything at all. There's no latent. So it's just going to cool. And that might be fine if you've got a 500 CFM dehumidifier, that's like a 200 pint per day. But the other thing here is this makeup air for kitchen exhaust, which I recommend here, which is what you see in Eagle's plan, is that the makeup air is delivered, bam, right there next to the range hood, which, by the way, they moved very nicely. I was like, this is not going to work. You should put it against the wall, and they did. So make the point. I've had people move their ovens from the wall underneath the range hood based on like explaining why this would be important. And they'll do it. So this thing now lives over here by the wall. We get the makeup air delivered right close to it. And that way, the river of air that's being just brought in raw from outside, even if we filter it, even if we preheat it, in summertime, it's got all this heat and humidity in it you can't take out, because a dehumidifier that runs like 800 CFM, let's just be crazy and say that it's a 1200 CFM exhaust hood. Makeup air that's 1200 CFM, that's a lot of extra stuff. So you want to make these things as close together. So it's just boom. If you dumped that into here and we had 1200 CFM coming in from outside makeup air, now all of the air that's being processed by this thing is coming from outside. And I don't even know, I think a lot of us would say, we don't know what is going to happen. So you don't want to do that. And also giving the makeup air over here, if it's like 1200, again, here, if you're trying to size something that's like 300 extra CFM coming into this, 300 extra on top of 1200 is like not the end of the world, but if it's 300 extra on top of a 1 ton, now you're basically doubling the airflow on this side. So now we need to figure out like what's going on over here. And that's why testing is so important. So anybody who's designing should also be out there testing stuff and knowing how they're working out. And that's, by the way, how we know that Manual J totally overestimates heat requirement. On my parents' house, which is not a high performance house here in Atlanta, Manual J told me, I did the boiler test, I did the Manual J, it said 65,000 BTUs per hour. Wintertime, 30,000 in the summertime. So what we did was install a 30,000 heat pump and then extra backup heat strips, which I turned off on 3 design days in a row and monitored what the temperature was, and it was perfectly fine. That 2.5 ton can carry the whole load for the house, 4 feet above the ground, 72 degrees, nonstop. When you're doing this, these bedrooms are now getting 176 CFM. That bedroom in the Manual J that was like before, in the Manual D, it was getting 50 CFM. So we could use the undercut on the door. Now we can't do that. We need to figure out how the air is going to make its way back. So you can use jumper ducts, you can use transfer grills, you can undercut the dome more. We can also, this is not necessarily what we're delivering. This might be 250 or a 50 and a 110, which is 160. So anyway, sizing this thing, but then do you want it to be able to work when it's on high? So this is the filter wall. It's just like right there. And that's what Matt was saying about like the equipment is literally in eyesight. So the sound is coming straight out, into this room. And this is a landing, on the second floor. So it's not a huge problem. But this then is what they did. They just put this like MERV, whatever, 3 mesh on it. And that was something that we all immediately were like, no, I don't think so. I think that I like that they came up with the idea. I like that they went around talking about it because like I'm interested, obviously. But I feel like a lot of us feel like the house in Houston that was the prototype, they didn't do exactly right. Like there are some improvements to be made. And so I think it's exciting.
How are you getting room 16 Matt in your house? In Eagle's house?
Oh, it's smaller.
Two big, 31 by 28.
What's largest AprilAire filter I can get? Looked at how big of an opening do I need to get? Design figure out that. So we've got 2 largest side by side. Design the return air pathway based on basically it's all around AprilAire.
So it's like a sheet metal duct.
In the mixing room or outside of that?
It's a mixing room.
So at what point, so the AprilAire is pulling air from the house into the mixing room, and that's where your filtration is?
Yeah, when it's going past AprilAire.
Yeah, the thing that's driving the air movement is those fans, those bath fans.
Oh, okay. So
Yeah, which again look like this. This is their array in that prototype house.
It's coming in.
Right.
They're all coming in through this giant filter.
Is that right?
This is going to be a nightmare for the YouTube. Sorry. Just.
High performance filters in the room, like, yeah, you can't do it that way. So I looked at this, like, well, how can I just have a wall of AprilAire filters across this, so I can control the air coming in and filter it out.
So you don't have a wall filter, you have multiple AprilAires that are filtering as it pulls air into the mixed
In parallel. It's a big return duct that comes out of the ceiling, takes a turn, and then bam, bam, filters side by side, and then it goes down into the, so they came up and down.
You could redesign, like, what we did on the plan, we pushed mixing towards the back, that space, and like the laundry room between, so that find a way to get air. But everything in the house is filtered 4 times now.
Corbett, is there a way to calculate the throw of these vents? I think that's what Mike was kind of getting at, because that was my
Yeah.
concern of like
And
the T.
do you want to posit what you think? You would run a manual, can you do a manual T on what we just did?
As long as you have the data.
What if it was 50, 80, and 110 switchable fan that might do any of those? Which, because it would whistle. If you sized it for the low flow, which is what we're ideally hoping it never kicks out of, then
They don't have, they're built, the diffusers are, the tolerance isn't 50.
Right.
I mean, it's not 30 CFM.
it's not 100%. Yeah, right.
You can't go that much range without having not the right throw.
Yeah.
I mean, if you're talking about like a 10x6 though, you can do 50, 80, 110, pushing it a little bit, but if you sized it for 80, then you...
Probably. And that's what we do when we size ducts in manual D, is generally sized for medium speed, because it's that way it's like,
I was going to suggest something. Whoever makes this, you probably make a lot of money. But like on cars these days, when they're warming up, they'll close louvers on the front.
who's our car guy? Hang on a second. Are you paying attention?
So to
Okay.
help
Electric cars, electric.
All right.
Enjoy yourself over here.
Go ahead, Fisher.
All right, so when you're driving, if you just turned your car on, it hasn't warmed up yet, it'll close the louvers that let the air into the radiator to cool the car off because it hasn't got heat to the engine yet. And then once you get driving and it's got the operating temperature, to open back up. So if you had a grill that had automatic louvers that would open and close based on a signal, then you can open it more.
They have that.
Now noise decibels
Yeah.
would be a different story, but
Right.
you know,
Yeah.
there could be some automation there.
Corbett, back to the manual T question, and in a
Nice.
high performance in the kind of homes we're talking about here, when you have the air tightness and the performance of these walls, we are putting our diffusers as close to, not in as close to the exterior wall, but the interior wall to stay closer to the air handler. And we're putting our return pathways on the other side of the room, so it does pull it across the room. But here's the thing about this type of home, the throw, I almost throw that out the window because I don't care about throw anymore, because this room, once you put it into an airtight room, and if it's balanced properly and you don't have an undercut because you're getting the right pressure in there, you're putting the air in there, it's going to get throughout the room. It's going to stay in there. It's going to get in there. And so we have airflows down in the 20 CFM in some rooms. So you're not going to you don't want high velocity you get it in that room, it's going to go there. So
Sure.
In terms of doing a manual T, it's starting to diminish the need to do that, because you just get it in the room in these types of homes, and it'll condition it.
I agree. Yeah.
And I don't, and the ceiling fans, you and I will arm wrestle over that forever. But because I'll do the return air pathway, I'll just pull it across the room.
Well, the return air pathway can be the door undercut too. And what Chris is saying though,
I'm going to arm wrestle on that one too, because they're going to block that thing.
I have smart clients.
Yeah, but the ones that move in after them are not so smart.
Yeah, I don't have any
And the guests
responsibility.
aren't smart, or
Yeah.
somebody's not
Well,
smart.
I mean, I hear you, but like running a full room return system also adds cost. And I'm just saying, door undercuts do work. I think that they'll block it off if it's a bathroom and they're taking a shower. I could see a towel being stuffed under there, but anyway.
We'll debate this over some pie.
Sure. If the house has an ERV and total idiot moves into it, I feel like that's like, there's gonna be problems no matter what. So the way that I do is I place the grills as far into the room as possible, and then I use the door undercut generally as but they do it in Florida the way that that's like standard is, like put it near the inside and you throw it at the window, I guess from the other side of the room. I don't really understand that, but again, arm wrestling. There's no right answer, there's no recipe for this. So just like, as long as we're getting the air and the BTUs and the, you know, that's it, yep, exactly.
Well, with the windows, the old school way is to blast the air on the windows, but you're creating a greater delta T now. So you're actually dealing with more of a load by conditioning the window. So now we're trying to get away from that window and then condition the room so it just is the room load and the air. So anyway.
Arm wrestling. Yes.
All right, so I'll stay in the skeptical production builder perspective.
Do we have the?
Yeah.
So I love the novelty of it, and I see the potential for custom builders going with the niche, you know, from a niche perspective. But do you see any of this that would be applicable, or any portions of it that would be applicable to kind of collaborate or partner with a conventional system in a scalable model? So for Loudermilk or myself or builders, I'm talking whatever, hundreds of builders a year to educate, okay, your low-hanging fruit. Is there anything here that we could apply in that sense?
I think I would recommend this one because it's just so experimental at this point. And like, if Eagle hadn't bought in, Matt would just be like bagging with him every day. Just like, hey man, we need to okay, just bear with me for a second. But Eagle is like, yeah, here's he was the one who brought the idea to us. He's forced us essentially to do this against our will, right? Yeah, but we're willing participants, So I think that, no, I would not recommend that you even mess with this right now. Once there's more information about it and more feedback, cool. But like right now, I think Eagle might be the first person.
Cheers, Eagle, for going. I love it.
Yeah, right. Yeah, thank you, Eagle, for getting us. Right.
According to Edison, there are some production builders doing something similar.
I'd love to see what that something similar.
Well, didn't Matt Reisinger have a mini split in the attic with holes in the ceiling?
I did not like that, actually. No, I don't think that. Because it's not circulation. When it's passive, Matt Reisinger teamed up with Habitat for Humanity, I think, in Austin. And they did this thing where they just mini split it into a conditioned attic. And they just had like vents, like passive vents around. My tiny house that you guys have actually seen, right? I have the mini split is in the dining loft. So like 4 or 6 feet ledge. No door on the dining loft, no door into the under sleeping loft. And the difference in temperature in the summertime is 4 degrees. It'll be 4 degrees hotter downstairs than upstairs. No door, no curtains, no nothing. So like, I'm just not buying that this passive, like with a grill, I don't think that really.
What was magic about the 4 air changes? That was the draw.
I think it was just old school.
Yeah.
That's what they wanted back in the day, was 4 air changes per hour.
That was the part I couldn't remember from Ken.
Yeah.
And you're saying you actually think it could be less, 3.5?
They said 4, but then they said 3.5.
Okay.
Because I think they know it's kind of overkill.
I mean, I just, because obviously you're trying to get good mixing,
Right.
really consistent temperatures, et cetera, but I'm just curious how that popped out.
I don't think we have many answers about this until we build a couple and figure it out.
I mean, I've been doing this in Japan for a while. This is not
Yeah.
over there.
In apartments, very low load, very small, few fans, yeah.
What percentage of your square footage, your built square footage, are you devoting to what percentage of your real estate are you devoting to your mixing room? Is there a formula? Because that's kind of expensive.
The fan size, the fan array, that was the problem with this 41 fan. I was like, hey guys, I built a 3D model of it. It's not important. I'll show you if you're interested. But like just boxes that are like this big. And I was like, you can only fit 3 across, and you need a room that's like 15 feet high to make this work. You do not have, this cannot work. So then they were like, oh, well, let's do 2 systems, the north and the south. And then I was like, great, still don't have enough room unless we turn the thing sideways. But then there's the air comes in and it has about 3 feet to mix and get all the juice in it before it goes. And there's like 100% chance that some of those fans will get way more dehumidification or way more humidification or way more cooling or heating than other fans, because the mixing needs like some space to work its magic before it hits the fan
I
wall.
think that's what she's asking. Is it still trial and error of what the cubic volume of that some space is?
I think be conservative like everything else. Just like try to make it big. That's what, you know.
I mean, you're saving a bunch of money by putting, a mini split in that a homeowner can change out and, dehumidifiers that I can go to Home Depot or Lowe's and buy, but at what cost
Sure.
of square footage?
Engineering is a series of compromises.
The Oasis house, probably 3,500 square feet, and then mixed room is at what, 8 by 6 maybe?
Yeah.
What size is yours? It's not the way that it's shown here, by the way. They've modified it slightly.
So I guess the question would be, how much real estate more than a standard mechanical room? Right?
I don't think it's actually that much bigger. I would recommend a big one. Yeah, I would recommend a big mechanical room no matter what. All right. So, any other questions, or do we want to like break up and do arm wrestles and arguments? Yes.
Could you turn it on its side and put it in a sealed crawl?
As long as it's a room, I think sure. Yeah, I would believe in that. A lot of people you'll ask are like, I don't want crawl space air in my house. You guys have been in my crawl space. I hope that you had a good time. But I think, yeah, I think you could. I have a client who's trying to do that the problem is though, with the like ideal that you were saying where we do this and when we do that, is there's always limitations. And it's like, we can't actually do that in this case. So this one guy is trying to, it's a brick colonial in Virginia, which is outside he's breaking the first rule, which is 40th parallel in the wrong climate zone. He's got a load on his mixing room, which is the entire crawl. He was like, this is what I want to do. And I'm like, we can try it, but I'm pretty sure, like, here are the challenges. And I think that that's our job really, is like all the time. If somebody wants to do something, you say, all right, here are the like opportunities for failure. I see your benefit, but like, here's what might happen. Are you okay with that? And then if you need to sign on the dotted line, you're okay with that. And then we can move forward, because like the best way to learn any of this stuff is the hard way. If you build your own house, you will know this stuff. That's why I am much more like, the Kool-Aid is inside of me because I live in a house that's got an ERV. How many of us live in a house with an ERV? Cool. Until you've like done it, you're like trying to explain what an ERV is. As soon as you live in a house that's got an ERV, you're like, oh, this is what an ERV is, because I can feel it. Like it's happening, all the time. So I highly recommend that you.
Can I just say, don't use your crawl space as a duct. I'm strongly encouraging you, because
You're not supposed to use framing.
some pest control person's going to spray poison in it. Someone's going to store a lawnmower in it. I'm just saying.
Not in mine.
Don't use your crawl space as a
All right, so let's commence with the arm wrestling. I will stick around. Thank you guys very much for coming. Yeah, thank you.